JJ Math. Let's look at the first part of factorization, taking out the common factor. So this is going to be your go-to with any factorization sum. This is the first thing you're going to look for. Doesn't matter how many terms there are, you are always going to check if there's a common factor. So how do I do this? You would look at the numbers first. So if I look at question A, there's a 4 and there's an 8. So I know that 4 can divide into both of them. Once you have the numbers established, you can write that in front, and then you move on to the first variable. So in this case, an x, I need to see, do all the terms have an x? And then what is the most x's I can take away? Remember, I can't take away more than there was originally. So then you write down the x next to the number and the least exponent that you can spot in the sum. Then you move on to a y and the other variables. You write that in front, make a bracket, and then in the bracket, you write what remains when you divided each term by that common factor. Let's do a few examples so you can see exactly what I mean. So in question A, I can see that a 4 can go into everything, and then I move on to the x's. So with the x's, the one has a 1 exponent, the other one has a 2 exponent. I need to take out the smallest one. Okay, I make a bracket, and then I'm just going to do extra steps for the first one so you can see exactly what I need to write in the bracket. So if I have that, I divide both by the common factor. So divided by 4x, divided by 4x. And then this would cancel out completely. So there's a 1. 4 goes in there once, 4 goes in there twice. And then 1x cancels, 1x, and there remains a single x. So that is what is in the bracket. Let's write it. And that is my final answer. Okay, sometimes it's necessary to look at the bracket again to just see, can I maybe do another common factor, or then move on to some of the other parts of factorization. Question B. So in this case, if I look at the numbers, I can take out a 3. With the x's, I can take out a 2, so I'm always looking for the one with the smallest exponent, so x squared. And then with the y's, I can take out y squared. What will remain if I divide each term by 3x squared y squared? This would be a 1. This would be a 3x squared y. And then with the last one, this would be a 27x3 y4 z4. Okay, question 3. Sometimes the bracket is the common factor. So then I just need to see, are the brackets identical? So in this case, if there's a plus between the terms in the bracket, I can just shuffle in any order that I want it. So in this case, I want t plus m. So in the last bracket, because there's a plus, I can just shuffle and I don't need to do anything else. Now the bracket is the same. I can take it out, it becomes t plus m. And then what remains is 3k minus 4p. There's nothing else common in any of the brackets, so that is my final answer. Question D. Okay, so now it gets a bit bigger, but it does not get more difficult. So in this case, I want the brackets to be x minus y. So the first one is correct. I can just leave it like that. In the second one, I can see the order is a bit wrong, but the x is still positive and the y is still negative, just like the first bracket. So I can just shuffle, even though there's a minus, the minus was not in the middle. We'll do, just now, we're going to do sums where the minus is in the middle, and then there's an extra step that you need to do. So in this case, the last bracket is fine. So I can just rewrite it. Now I can take out one of those x minus y brackets from each term. So x minus y. What remains is x squared plus x squared y. So now I can see I'm going to be left with one of those brackets in the middle. So then you must actually do a block bracket, and then x minus y minus x, close the block bracket. So whenever you do factorization and you see that you're going to have brackets in brackets, then the biggest set has to be block brackets so your teacher can see the difference and that you can see the difference. So now to finish the sum, I need to multiply or distribute in the second term. So the first bracket just stays like it is, x minus y. This now becomes a round bracket, x squared plus x 3y, and then minus x squared y squared minus x, close the round bracket. That is my final answer. So it gets a bit tricky, but just follow the same steps. Now we're getting to another part of the common factor, and this is where the brackets look very much the same, except there's a minus in the middle, and the order is wrong. So now I can't just shuffle them like if it was a plus. I can change the order of a bracket if I put a minus in front of that bracket. Now, if there was a minus already, it would change it to a plus. Let's look at the sum. So, okay, x minus y. Now I can see, okay, that second bracket is not x minus y. So I can swap the order if I take out another minus. So this becomes x minus y. And then in the final answer, that minus minus will become a plus. So now I have a common factor of x minus y. And what remains is k plus 2. There we go. So you can switch the order if you change the sign. That's why it's called the sign change rule. So always remember that one. Question B. So now, once again, the brackets look the same except for the order. So m minus 3n. And then this becomes a minus, because I'm taking out a minus, and a minus times a plus is a minus. M minus 3n. Now, for my final answer, taking out one of those brackets from each term, and then what is left is 7x minus 4y. There we go. In the next one, sometimes you can do it twice in a sum, depending on the amount of terms. So in this case, I need to decide, do I want x minus y or y minus x? I don't like putting a minus in the first term of my factorization, so I'm going to swap the ones on the right. So the first one stays the same, a x minus y, and then this would become minus minus, so plus, b x minus y, and then minus c x minus y. Okay, you could have done it the other way around and just swap the first one. That's 100% fine, as long as you show it correctly and your signs are correct. Now I can take out a common bracket, x minus y, and what's left is a plus b minus c. Final answer. Question D. So in this case, again, going to swap the second bracket. So this remains 4x cubed k minus p, and then minus minus, which becomes a plus, 8xy k minus p. Okay, now I can take out that bracket. That's very obvious, but I can also take out something else, because 4 can divide into both terms, and 1x can be taken out from both terms. So my common factor in this case is actually 4x, and then k minus p. So what remains then is the 4 is gone, so that's just an x squared. I took away 4 from the second term, so that must be a 2, and I took away 1x. That would then be my final answer. Okay, that was taking out the common factor and sign change rule. I hope it made sense. You can see the steps in the blocks, but yeah, just practice this. It's going to be in every single algebra section that you're going to write exam about. Make sure that this makes sense, and then we can move on to the other parts of factorization.
If this video helped you, please like and subscribe.
JJ Math.